So I wanted to make a couple announcements to start off our class. Next week is, so the end of today, we're already halfway through. So that's pretty crazy. And next week, week 5, we're going to start with a quiz. So our quiz is going to be what is it? Single contact paper plot. So you, with your quizzes, you can look at your notes, you can use your materials, whatever you have. But just so you know, it will be a graded quiz. Like our homeworks right now are just kind of tell me you're doing your homework and I believe you honor system. So with the quizzes, it will be graded, but you can use your notes and things along the way. So I just wanted to let you know. So next week we will have a quiz. And then so next week we are going to start, or I'm going to touch a little bit on radar navigation before we do multi-targets. And on radar navigation, I wanted to ask you guys, is there a specific chart that you have to use for another class that you guys have? Like, I don't want you to go out and get a chart just for this one little section. Like, what do you use in your other classes?
I know that
for
coastal
navigation?
Yeah, coastal navigation used one that like had the sailing center, Newport. I don't think we used any. Did we use anything else, Sabrina? I think it was like a local.
No, sorry, I was on mute.
The wedge. Yeah, like the wedge, or what chart have you used anything in coastal navigation?
I have not been in coastal navigation. I missed the first part of the question. Did you say about the charts? Because I do have,
Like
charts.
what kind of charts?
I want to say that. Yeah, I think we used one that had like the sailing center on it, like a local chart, and then we used one going to Catalina.
Okay.
Do you need this chart?
What about?
Yeah, maybe like that.
Okay.
754 Newport. Today in boat handling, we went over a lot of charts, like vector charts, raster. We went over a lot of charting today.
Yeah.
Okay.
And I think all my charts are on my boat.
But I don't know if that answers what you're asking. I could be way off. But
is that the only chart that you have, Sabrina?
I have some other ones, but they're used. I bought them for $1.
Used is totally fine.
Like Chesapeake Bay, like not Newport Harbor, like
so Chesapeake is the training chart, which you'll be doing a lot of prep stuff on. What about you guys, Joseph, Lucy, and Louise? Do you guys have any charts? I might just do a.
No. We don't have any on us currently.
Okay. Okay.
Do you see that the Chesapeake is the training chart?
Correct. It's Chesapeake, Long Island, and Block Island. That's what the U.S. Coast Guard tests you on.
Get out. I have that one.
It has to be the actual training chart.
Oh.
It has to have TR on it.
Like chart. TR 1099 or something like that.
Yeah.
Yeah, I think I got that one. Yeah, Long Island, Block Island.
Chesapeake.
Yeah.
Okay.
Got that from captain class.
Okay. We'll see. We'll see what I come up with for that. Okay, so quiz next week. This week we are going to review a little bit of our paper plotting, and then we're going to dive into the second triangle. So basically collision avoidance. Last week we figured out what the relative motion line is. So if we don't change course, they don't change course or speed, we don't change course or speed, what's their relative motion going to be? Are they going to hit us or not? And or get close to us in a comfortable area or not comfortable. And so we kind of identified that. So I identified CPA, which was closest point of approach. We identified time of CPA, distance and bearing of CPA. And then we also did the targets or the other ships, true course and true speed. So we could figure out what type of situation this was. So is it a meeting situation, overtaking situation, head on, and who has the right of way, give way, or stand on. So today, we are going to identify if we have to change course, what course do we change to in order to avoid them? So instead of just being like, oh, I'll just turn right to see if it changes, we can calculate exactly what course we need to change to get the exact CPA that we want. So that's what we're going to be focusing on today. And that's it. What I want to say. For today's, we're going to do the PowerPoint, which has a few examples in it, but I'm just going to do the PowerPoint, and then I'm trying to find it. Our in-class practice plotting says second triangle. I literally just printed it out. There it is. Second triangle. So this is what we're going to do in class. I think there's 5 questions on this guy. So get that printed out if you don't already have it during a break or something. And then if we have time, we'll get to the homework as well. Okay. Any questions so far?
No, just what I mentioned to you earlier, kind of like, I'll probably need like a refresher.
Yes. Okay. We will do that. And I did want to remind you guys to do the to on Canvas submit the homework assignment. Super easy. You just put in a date, but I just need you to acknowledge that there was homework and you submitted it. So please submit those.
Do you need like a picture of our plot?
No, it's just put in the date and you submitted your homework. The quiz will be graded though. So these homeworks are just kind of like a little warm up for yourselves, but the quiz will be graded. Okay, so let's get started. Oops. Okay. Okay, so today we are doing our second triangle, which is basically our collision avoidance. So I just like to keep showing you guys different pictures of radars so you can see different images on the screen and see how things can change. So on this specific image, I'll point out a couple things here. We have the coastline, right? We have a coastline here and a coastline here. So we're in some sort of channel. We can't see much this way up to the north because we are down here, and with radar, you can't see past the mountain, right? Or past all those targets are getting sent back. So we can't see on the other side of it. So we do have this large blind area up there on the upper left-hand side. But we can see the coastline, and then, you know, everything behind the coastline is just kind of spotty. We don't really know what's there because it's the coast, land, essentially. We do see on this one a different color of the trail. So the trail is that history, and this one's kind of faded, or ombre, that's what I was looking for, like an ombre effect. But that kind of gives a true vector, where that relative vector is what's telling us if they're going to hit us or not. Other things I see on this chart is they have plotted a track line on their radar. So this green line to here, green line and green line there, is actually a track line. So this is the vessel, they're offset. This is the heading flasher. So they are a little bit to the right, of course, or right of track. But yeah, does everyone kind of understand what's going on this screen there? Okay. We have a VRM and an EBL. Their VRM is at 0.3 nautical miles. EBL is pointed that way, 131. But anyways, I just wanted to show you another radar screen. I know you guys probably aren't seeing them in real
Captain
life.
Bree?
Yes.
Captain Bree, could you refresh us on VRM and EBL?
Okay. VRM. So what do you think the R stands for?
Range?
Range. So variable range marker, VRM.
Cool.
EBL is bearing, B. So it's electronic bearing line.
Line. Okay.
Yeah.
That's what I thought. Thank you. Okay.
Okay. Okay. So these are some of the abbreviations we worked with last week. Let's see. I kind of actually want to do a review first. Stand by. I think most of you guys said we want to do a review. I'm actually going to bring up. Oops. Okay. Well, sorry, that scared me. Okay, we'll review this part first. So when we see a blip on the screen, a target of some sort, just a blip, we want to get the range and bearing. So we're going to use that EBL and VRM. So electronic bearing line, and that EBL is going to be in the middle of the blob. So however big the blob is, we're going to go to the middle of the blob to get the bearing. For the range, we're going to go up until the very edge, the closest edge to us, to get the range. So we mark down, 1826, range 10 miles, bearing 045. So that's what you take note of when you see something. So we mark down the time, the range, and the bearing. And that first little blip, we're going to mark on our paper as R. Then we're going to wait 6 minutes, or however long you're going to, but it's a lot easier if you wait 6 minutes, and get the range and bearing again to the middle of the blip and then to the closest edge. Range and bearing 6 minutes later, mark that on your radar plotting sheet with an M. Then if you connect those, we get the relative motion line, the RML. So that means if I continue on my course and speed, they continue on their course and speed, this is what will happen. They will continue down the relative motion line. Now, to plot the E of our triangle here is plotting the other thing we know is what we are doing, our heading and our speed. So we're going to transfer from the center, E. In this case, I am going due north. So from R, I do a reciprocal, so I can go E to R is what I am doing. That is my vector, my own ship, E to R. So however fast I'm going and whatever my course is. Then I can connect E to M, them. E to M is them. Excuse me. And there I get what their course and speed is. So then I can identify what kind of situation we're in. So
still have trouble understanding how E gets to that spot.
Okay.
But it could be the cough syrup.
Okay, so here's the example with sound effects and all. We're at the center. My own course and speed, own ship course and speed is due north. First blop or first blip on your screen, we mark R. Then during the 6 minutes, you transfer parallel your own course and speed from R and you mark it E. You can do that in the 6 minutes.
So whatever R moved in 6 minutes time, you mark E behind it?
No. So I was talking before how, let me go back to this one. You mark R to M, plot the relative motion line, get your CPA. Okay, we know that it's risk of collision. Then I'm going to plot my E to figure out what they're doing. So that's how I kind of do it on the paper plot. But in reality, and how Captain Ron likes to teach this speed plotting is when you're waiting for that 6 minutes mark, like 6 minutes is a long time. So he's like, do something during that time. You know what your course and speed is, so draw that E line while you're waiting 6 minutes. So let me go back. Okay, so we blip on the screen, marked R. We're waiting to mark M. So during that time, we're going to transfer over our own course line and measure our own speed. So it's our own. We're creating our own vector. So we mark that E.
Got it. Okay.
And then 6 minutes later, we mark the range and bearing. Mark it M.
Yes.
We connect R to M, and we get our relative motion line. If we connect E to M, we get their speed. The closest point of approach, so R to relative motion line, R to M, wherever the closest point that gets to the center of our circle is our CPA. How I like to do that is a right angle to our relative motion line.
Right. I got you there. Okay.
So that was a quick little review. Let's go back to week 4 here. Okay, so our abbreviations, and on Canvas, there is a list of acronyms on the reference material that is very handy. So you might want to look at that as well. So R to M is relative motion, right? That one's kind of easy to remember. E to R is your own ship's true course and speed. I don't really have a great memory aid for that. E to M is them. So it is, their course and speed. And then we have a couple new abbreviations. Well, at least for these, on your radar plotting sheet at the bottom, it tells you this. So if you can't remember, reference the paper that you're using. So it tells you true course and speed, that's your own ship's true course and speed, is E to R. The other ship's true course and speed is E to M. R to M is always the direction of relative movement. So use that as your reference. I think everyone has it on their, unless you have like a really old one or something, everyone should have it on their radar plotting sheet. So now we are going to talk about a few new points. We had our CPA, our ER and M, and now we're going to talk about MX, and that is our execution point. So this can be a time, this can be a miles, a distance, this can be, either time or distance of when are you going to turn, if you have to. When is that point of execution? So you don't if a guy's 10 miles away and our CPA is 0.1 and we're not okay with that, we don't have to change course at 10 miles out and completely avoid him by 10 miles. 10 miles is a huge distance, right? If we were on the freeway, we wouldn't be steering clear 10 miles of someone. So we want to steer clear, however we're comfortable with. So that's going to either be given to you in the problem, be given to you by the captain, whatever it is. And we also don't want to steer completely off our track line to avoid someone. So we're going to wait until, not necessarily the last minute, but wait until this point of execution to change course. So that point of execution is going to be given to us. Then we're going to have a new R. So sometimes it's written like R prime with a little apostrophe next to the R, or it can be the RC for a new course change, or RS for the revised speed change, whatever change you're going to make. Are you going to, change your speed? Are you going to change your course? We're somehow going to change that R so that we're changing the relative motion line so that our CPA is not 0 or risk of collision, right? So we have this new R. So R prime, RC, RS, you might see it a few different ways. And then we're going to have R new course, which I don't really, it's more like E to R prime is what your new course is. I don't really write it NC, but anyways. Okay. So our radar transfer sheet, we're getting used to this. Oh, okay. First, let's go over some 6 rules for direction of relative motion. So again, our relative motion is what's, actually, let's look at the video again. I think the video helps with relative motion. Sorry, I keep. Okay, can you guys see the video? Okay, yes. So right now on this simulator screen, we have a couple different blips, and they're required, meaning they have a vector line. And the vector line right now is in true. It's T vectors, so they're in true vectors. So this vessel is going this way. This vessel is crossing us. This vessel is crossing us. These little vessels here are not moving. They have no true vector. But when I change it to relative vectors, so we have R vector. So this is your R to M line, your relative motion line. This is going to be their relative motion. So if I continue on my course and speed, these guys over here are going to pass behind me. That's their relative path. They're going to pass behind me. These guys who weren't moving at all, their relative path is reciprocal of what my course and speed is. So they're not moving. They're dead in the water. They're just going to continue on. Their relative motion line is opposite of my course and speed. Okay. I'll play it again. It'll go back and forth.
Captain Bree, could you have changed that orientation to heads up, like flipped it?
So you can change it to heads up, and that helps with what's looking out the window, but it's very confusing to go back on the chart. Excuse me.
Gotcha. I was thinking
is north
the reason it's oriented that way is because that's the way you're actually driving.
Yes.
Okay.
Okay. Okay. So
can you change how much?
Yeah.
Can you change how much it projects forward or shows trail on you?
Yes.
Okay.
You can change all the trails. You can change the length of, I think on here, so it says trails are permanent. So since I started transmitting, they're permanent. You can do, 6-minute trails or however long. And then I like doing it where it's like a 6-minute trail or a time, because then you can see which ones are moving faster, which ones are very quick moving and which ones are very slow moving. And then your relative vectors you can change. So here I have it at 16.7 minutes, but you can change it to whatever length you want. But we are doing this all by hand.
And you can do that on the targets or yourself, right?
Correct. Okay. So when you change the vector, it changes the vector for everybody, for yourself, for the targets, for everybody. So we are going to be doing this relative motion and true motion on the paper by hand. Most vessels have ARPA now, which gives it to you digitally, but we are learning to do it old school. Okay, here we go. So when we look at the relative motion line, so we're all on relative vectors. When we look at the relative motion line, these are our rules. I think I'll go back to it after we read the rules. Okay, so when you reduce speed or stop or go astern, all the relative motion lines tend to move up scope. So they will move up. Your relative motion lines will move up when you tend to stop, I guess. When you increase speed, your relative motion lines move down scope. When your ship changes course, a down target will change its direction of relative motion in the same direction that your ship changed. So we're going to see all of these happen on our examples. An up target will change its direction of relative motion opposite of your ship's turn, which we're going to see, because we're going to change course and see how that affects different things. Depending upon the direction you turn, the limbo target will become either an upscope or downscope target and will react accordingly. That's confusing. Okay, these seem very confusing to me. Let me go back to my video. So when we're looking at our relative motion lines, I think I make them longer. Let me find it. True. There we go. These are super long relative motion lines. But if you change, these lines will move one way or another. So looking at this, I know that these guys are going to pass behind me. So that's a quick reference, which I think is the most important to see, is it a risk of collision or not? And then you want to know how I move is going to affect their relative motions, right? So let's get into the PowerPoint, and I think it'll make more sense. And we'll look at those rules at the end of today's class, and hopefully it will make more sense. Okay, so we are going to be focused on maneuvering for context or collision avoidance today. So basic rules of the road. Where are my boats? Hold on.
We have to plot that on the test.
Plot what?
The
collision?
what you have there maneuvering for. Yeah, do we have to plot the collision?
Well, we're gonna avoid the collision. Oh my gosh. I have too many things. Sorry. My favorite boat is gone. Okay, I think I have to get another boat.
Did it capsize?
I think my niece probably took it. Okay. We have a little dinghy. Maybe that'll work. Okay. Okay. So these are two power-driven vessels. We have a meeting situation. In a meeting situation, who is give way?
Both parties pass port to port?
Yes, both parties are give way. Both vessels need to change course to starboard and pass port to port. So that's head on. Overtaking. Here we go. Overtaking. So if I'm overtaking this guy, who is give way?
The boat that you have your hand on.
Yes. So the boat that is doing the overtaking is give way. So the overtaking vessel is give way, and they can pass on either the port or the starboard side. The overtaken So this little dinghy is the overtaken vessel. They are stand on. They need to maintain course and speed. And then we have the meeting situation. So in a meeting situation, is it the container ship or the dinghy that is give way?
The dinghy is stand on, so the container ship is give way.
Yes.
It's like at a stoplight.
Yes. So we have our red and our green, our red and our green. So we have this guy is seeing red, so he has to give way and turn to. Most of the time, it is suggested that you turn to starboard or you slow down. So if we look at, if this guy, use a different color here. Can I see it still like this? Let me change it like this to kind of go back to what we were doing in class. So our relative motion line is something like that. This is our relative motion line. With this guy, he is going this way, and I am going this way. Now, if I want to change that relative motion line, and I want to pass astern of him, that means I want my relative motion line to cross in front of me. If I want to pass on his stern, I want to change that relative motion line to be something like this. So I can turn, and that relative motion is going to travel along this way as I travel along this way. So we are bending our relative motion lines today. But when we out which situation it is, that is when we figure out which way we're going to turn or slow down or any of the above. So just keep those three situations in mind. We have meeting, overtaking, and crossing. Okay. So our MX, our point of execution, is when we make that change. So it'll either be time or distance, however it's going to be given to us in the problem. And then we have our CPA. So we see what's actually happening, and then we have the CPA that we're comfortable with. So do I want a 2-mile CPA? Do I want a 3-mile? Do I want a 1 mile? What am I comfortable with? So it can kind of be called a danger arc. I don't want anyone to come within this, within this scope or within this CPA of me. So yeah, your contacts will not be allowed to enter this area if I have to change course or they have to change course depending on whose stand on give way. So that CPA, our original CPA, we find, and then we create a new relative motion line by using our own CPA, kind of creating our own CPA, which will be given to us in the problem. And with that, we have our new relative motion line. So RML, relative motion line, we are creating a new relative motion line. And that line is going to be drawn from the point of execution. So when we turn, that's when we are bending that relative motion line and creating a new one. So that relative motion line is going to be on the outside of our comfort zone, or our CPA that we're comfortable with. We're going to get to an example, so hope it'll make more sense. So R prime, or whatever the new R is, if you're changing course, you're changing speed, you can do RC or RS, as long as you know what it is. I'm fine with however you want to label it. Is going to be your new course or your new speed. So we created a new relative motion line, and then we have to transfer that relative motion line back to our triangle. So we are going to then create a second triangle and figure out what our new R is, whether it's course or speed. So we have a new E to R1, meaning us. E to R is ownership. So what is my ownership that I'm doing? And then we have our new relative motion line. Okay, so here's a little symbol or a little diagram. So we have R to M. Our heading is due north. So we have E to R is our own ship. E to M is them. So if I want to change my relative motion line, so it's not going through my center, I create a point of execution. So this was moved from M, so I'm assuming that this point of execution is a time, but it could either be time or distance. So we have a point of execution. From this point of execution, I'm going to bend this relative motion line to not enter my CPA safe zone. So here I bent the relative motion line so it stays outside of my CPA. So this is my new relative motion line. How am I going to get this vessel to stay on the new relative motion line? I'm going to move this new relative motion line back to the other M. So this was MX, my point of execution. I'm going to move this line back to the other M and draw it the opposite way. So that is my new relative motion line. It is going that way. So now I have E. Here's my relative motion line. So my R needs to be somewhere on this line. If I change, why is it doing this? If I change my course, so let me go back. So if I want to change my course, so E is my start point. E is the start point for both true course and speed for myself and true course and speed for the other vessel. So if I want to maintain my speed but change my course, I need my E to R to be somewhere. This is my new R relative motion line. So my R is going to be somewhere along this line. If I want to maintain my speed, I keep that distance on my dividers, and I basically swing an arc to see where it crosses my relative motion line, and I mark that as my R prime. So now my E to R prime is my new course. That is my new course that I am going to be changing to. Let me see if this is doing. Okay, do it on the PowerPoint. But if I want to change speed, maintain my course, maybe I'm doing something, towing something, having fishing gear out, whatever it is. I don't want to change course, but I can change speed. My course is going to change, but the speed. So I always start from E, and where my R has to be somewhere along this line. So where these two cross right there, that is going to be my R prime. And my E to R prime is going to be my new course and speed. It would be the same course, but a smaller speed. And we use that distance scale to go back to speed. So we have E to R prime for speed. And I think I have another example, but if we're changing course, it's the same length. E to R will be the same length, but our R prime will always be on our new relative motion line. Okay, these are what if your vector, what if your triangle isn't a triangle? So we've been doing all of these and it's this cool triangle and it's always off the starboard side, right? We're looking at it and they're always perfect, but it's not going to be like that always. They might be someplace else and it might not even be a triangle. So what does that actually mean if it's not a triangle? We go back to our same, what is R to M, what is E to M, and what is E to R. Those three things that we started this PowerPoint with. So we always want to think about what those three things are. So let's talk about the first one here. Relative motion, R to M. So R was where I first marked it. M is where I marked it a second time. So it is coming straight down, relative motion line, R to M. And then E to R is me. That's what I'm doing, own ship, E to R. So E to R is opposite of relative motion line, right? It's going due north. And then E to M is them. They are going due south. So this would be a meeting situation. Okay, so overtaking situation, we'll start with relative motion line. Relative motion line, we started off with R, and then we marked M. So it looks like, well, it's going R to M. Relative motion line is coming to the south. But then we have E to R is our own, right? That's my own ship, E to R. So I am doing a much higher speed than E to M. They are doing a much smaller speed. E to R, that means I would be the one overtaking. This should be overtaken. Oh well. Again, E to R is me, my own ship, that's the green. E to M, them, they are going much faster than me. They are overtaking me. Dead in the water, right? We don't have a triangle at all. Our E and our M are at the same points. So we have an R, and then we have an E and an M. Same course and speed means that we marked it 6 minutes later, we marked it and it was in the same relative point as us, meaning they're going the same course and speed as we are. Okay. Let's look at another example.
Captain Bree?
Yes.
Could we possibly get a pee break?
Oh, yes, we can. 7 o'clock. Sure can. Let's take
Awesome.
a 10-minute break. Wait, let's get started again. Let's see. Okay, so we have our kind of new points of our plot to make that second triangle. And we are going to look at another example. And of course, our example is going to be in relatively the same area because that's how all of them are for some reason. But I promise you our practice problems will be a mix. Okay, so we have our transfer plotting sheet. And the first thing they do here is plot. Okay, so in this example, they use T instead of E. I know that's very confusing. I'm just going to maintain the E thing. The E, that's how it is on the radar transfer sheet. That's how it is in the book. They're trying to like redo it and make it a T. So true motion makes more sense. But I don't know. I'm still keeping it as an E. But you might see it as a T. It's just different people do different things, I guess. Okay, so they plotted my own ship's course and speed. So we used our course, 0, 0, 0, our speed was 20 knots. So in 6 minutes, we're going to travel 2 nautical miles, right? We just move that decimal place over 1 using that 60D street calculation. So we can do the whole 60D street formula, or we do it on the 6 minutes and just move that decimal place over. So I have to 2 nautical miles is my E to R. Then at minute 0, I get a blip on the screen. I mark that as R. During these next 6 minutes, I transfer over my own ship's vector. So that would be my E to R. So I transfer over my own ship's vector. And 6 minutes later, I plot the blip again with the range and bearing that I've gotten from the radar. Range and bearing, so I could plot my M. And that's 6 minutes later. I connect my R and M to get my relative motion line. And that will give me my CPA. I'm not okay with the CPA. So I need to determine, do they have to change course or speed, or do I change course or speed? Who is give way, who is stand on? So what helps me decide that is seeing what their true course and speed is, what their true motion is. So if they are headed this way and I am headed this way, they are stand on and I have to give way. So I need to give way of this guy. So I need to bend this relative motion line. So in this case of a task of mark MX, my point of execution, at 5 nautical miles. So they told us just 5 nautical miles. That is going to be my point of execution. So right here, when the guy gets to 5 miles away from me, that is when I'm going to turn. So there's my point of execution. And I want him to stay 2 miles away from me. So I'm going to create a new relative motion line. So from my MX, tangent, so just right outside of my 2 mile line, my 2 mile range frame, if you will. So just right outside of my 2 mile range line, that's where I want him to travel to create a new relative motion line. Okay. Then I need to transfer this relative motion line back to the M of my triangle so I can create a new triangle up here. So I need to move this line back to this M and create a new R. So I'm going to parallel. Okay. Trying to skip over the guy talking. So we just paralleled this new relative motion line back up to the M and draw it again. So we just paralleled that relative motion line. So I know from my E down here, if I'm going to change course, my R, it has to be somewhere along my relative motion line, right? R to M. And this is my new relative motion line. So I need to put my R somewhere along this line. And my own ship's course, or my own ship's vector, is going to help me determine where I'm going to put that R. So if I want to change course, I keep the length of my E to R, and I just swing a little arc over to see where it would cross the line, and that would be my new R, my R prime, or RC in this case. And then to get what that new course actually is, remember to measure a line, we always have to bring it back to the center to actually measure the line on this thing. We can't just see it pointing to the edge and call it whatever it's pointing to right here. We have to bring it back to the center to actually measure that line. If we want to change speed, our R is going to be somewhere along that line. If we maintain our course, The direction of our vector isn't changing, just the length of our vector is. So our R prime would be right there. So this would be our new triangle, right? The smaller triangle. In this case, our new triangle is R to M and E or T. So R, M, and E. It's kind of this big triangle, but it's on its side. And our speed change gives us a small triangle there. So the E to M, the M side of the triangle doesn't change. It's the other ones that do. We're moving the R to create that new triangle. Okay. We already did direction relative to motion. We already did CPA. I don't know why it's doing it again. Okay. Plot exam tolerances. So for a bearing, a new course, or a bearing of any sorts, we have plus or minus 10 degrees. For time, we have plus or minus 3 minutes. For speed, plus or minus 3 knots. Always maneuver with rules of the road. So essentially that always means turn right. And don't cross ahead of anyone. So we always want that relative motion line to be ahead of us so we don't cross in front of them, meaning we're going to their stern, they're crossing in front of us. We're not charging in front of them and they're crossing behind us. So always follow the rules of the road. And this says maintain a 2-mile CPA, but it'll give it to us differently in each question. So let's do some examples, and hopefully this will start coming together. So get out your radar transfer sheets. Hold on. Okay. Okay, and most of you guys are using the roll plotter. I also like to use the triangle. We have our 2 little ships. Okay, so we are going to start working on the second triangle. I'm kind of thinking, do we want to start with the first triangle one? How far did you guys get through on that? Did you finish all of them? Let's just start with this one. That's what I have on the homework to do. So, okay. So for problem 1, it gives us our own course and speed, and then it tells us at a certain time we spot a target at a certain bearing and range. Now we got that from the radar. 6 minutes later, we got that range again. Standing orders tells us that we want an MX of 5 miles and a CPA of 3 miles. And now let's figure out what we're going to do. So I'm going to start with what they told us. I am on course 070. So I'm going to plot my heading flasher, what I like to call it. So I am on course 070 at a speed of 16 knots. Let me see. So I'm going to say own ship 070 16 knots. Okay, and then it said at 3:06, you sight a target on the radar bearing 015 at 10.8. So I want to plot 015 at 10.8. So I'm going to use a scale of the 12 miles. So my 10.8 is going to be somewhere along there. I'm going to use the 12-mile scale there. So I'm going to find 10.8 miles using my dividers. So there's 10.8. And what do we label that? R. So I kind of make it a circle here just so it's visible. You can just do a dot, but I'm just trying to make it a little more visible for everyone. So that is R. And I'm going to label that as 0306. Okay. So I have one dot. Then I'm going to label 6 minutes later, the target was observed bearing 016 at 8.3. So I'm going to find 016 at 8.3. So let's find 8.3. And what do we label this one? M. And that was at 0312. So we have our R and our M. Now we can connect those and we get our RML, our relative motion line. So they don't ask us for the direction of relative motion, but they do ask us for our CPA and our TCPA. So our CPA is going to be where this relative motion line gets closest to us, meaning the center of the scope here. Where does it get closest to us? So I like to use the triangle to get a perpendicular line to the relative motion line and the center of the radar plotting sheet. And this would be our closest point of approach. So it's, however far away, it's closest as it's going to get, and then it's going to go farther and farther away. So right here,
Was there a connection issue or did she kick herself out?
I was just trying to figure that out too, if she accidentally kicked herself out. I've been having internet issues all night too, though.
Were you having, I'm sorry, you're in the boat handling class as well, right? Boat handling?
Say that again.
Were you also?
I'm not in boat handling. I've got maritime and I'm in
okay.
maritime environment and maritime industry.
I was going to say boat handling this morning was also kind of shaky with the connection, so it's possibly just the update.
Yeah. Could be, yeah. Then again, could be the tequila. Hey, I feel bad that it's just me as the only face she sees. You guys gotta like come on in. You know, Captain Prelo would be like shitting baby elephants if we didn't all have our cameras on. So it can't just be me. Somebody else has got to chime in here.
More of a connection issue. I got 3 people right now using Zoom, and it's
Sorry.
hello.
Oh, geez. Okay, yeah. That'd clog anybody's drain.
Okay. I'm back.
Hey, we were just speculating.
Okay. Ay, ay, ay. Okay. All right, so what did I say last? Was I getting the CPA, I think? Okay, so we got CPA.
I think that was it.
So we measure the distance of CPA. So our CPA is 0.6 nautical miles. And then we wanted to know the time of CPA. So we use that 6 minutes, right? This is our relative motion in 6 minutes. So I kind of walk this over. That's where it's going to be 6 more minutes, 6 more minutes, 6 more minutes, 6 more minutes, etc. So then I'm going to mark these. So this would be at 03:18, 03:24, 03:30, and 03:36. So my CPA maybe right in the middle of 30 and 36, maybe a little bit closer to 36. Again, this is plus or minus 3 minutes. So if you're ballparking it, you can, what I mean by plus or minus 3 minutes, that's the, what am I going for? The wiggle room, the error margin, whatever. Okay, so I'm going to go with 03:33 is the time of my CPA. They got 03:32. Close enough. Okay, so then it asks us, what is the contact's true course and contact's true speed? So on my triangle up here, I need to put my E somewhere so that I have a triangle. So let me erase this real quick. Just gonna put it on the other side there. Okay, so I am going to parallel my 070. So there's, let me do it like this. My 070 line, that's my course. I'm going to bring it up to the R. So I'm going to put my pencil on R, and I'm going to parallel my course. Now I need my start point. So my speed was 16 knots. So in 6 minutes, how far will I have traveled? We just move the decimal place over 1. So 1.6. So I have 1.6 right there. So from my R, this point here is going to be my E. So let me erase this. So E to R is my own ship. So if I look at my rules down here at the bottom, E to R is the true course and speed of my own ship. So this course of this line is 070. The length of that line is 1.6 because we have a 6-minute triangle. And I'm going 16 knots. So E to R is my own vessel. R to M is the relative motion line. E to M is them. E to M is what they are doing. So let's connect E to M to see what they're doing. I'm also going to parallel that line so I can get the actual course. So their true course is, their true course is 152. What's their true speed? We get their distance traveled in 6 minutes, and then we convert that to speed, distance, speed, and time. So in 6 minutes, they will travel 2.1 nautical miles. That means their speed is 21. Their true speed is 21 knots. So this is them, and this is us. Who is giveaway? This is an interesting question. So we are stand on. They are give way. We are to starboard. They see our red light. So we are to stand on. We are supposed to maintain course and speed. For some reason, it tells us, I already don't like this question. At 5 miles, we're going to change course to port and get a new CPA. Maybe they are restricted in their ability to maneuver or something. We have to give way to them for some other reason. Okay, they want us to change course to port. Okay, so those are our vessels. We have an MX of 5 nautical miles. So I am going to make a 5 nautical mile circle. So when this vessel or any other vessel is within 5 miles, that is going to be my MX, my point of execution. My CPA is going to be 3 miles. So I don't have a 3-mile ring, so I'm going to draw in a 3-mile ring. So within this 3 miles is my danger zone, right? I don't want them coming within my 3-mile ring. And right now they are definitely coming within my 3-mile ring. So they are telling us that we are going to change course to port. So I want to bend my MX line. I'm changing course to port. Let me think about this for a second. That would be right. So I'd have to change it this way. Okay. I had to think about it there for a minute, which is totally fine. We are going to bend our relative motion line to this side of us. So I put my dot on MX, and then I'm going to measure this, or I'm going to move my ruler or straight edge to where it just hits that three nautical mile circle. So a tangent spot on that circle. So that is where I want the vessel to follow, to stay 3 miles away from us. So I am going to move this relative motion line back to my relative motion line up here. So I parallel it to this M, and I draw it out. So this is my new relative motion line. This is my new relative motion line. So I've now changing my triangle here. I have my E to M is them. They're not changing course and speed. I need to put my R someplace. And they're telling me I'm changing course, not changing speed. So I maintain my course or my speed, so that distance, that 1.6, and I swing this arc to the left. So from me, I'm swinging the arc to the left, which is changing course to port. Now, typically, I always say you swing the arc to the right because we're always changing course to starboard. For whatever reason, our first example here is change course to port. As you can tell, I don't like it. Okay, so where does this arc cross my new relative motion line? Let's see if we can zoom in on that. So where does this cross our new relative motion line? That point is going to be our new R. So this was R, so this is going to be R prime, or a new R. So now we're going to create this REM triangle using our new R. So them, they didn't change course or speed. The new relative motion line was the one I created because I wanted them to stay 3 miles away from me. And then E to R is my own ship. So that's how I can figure out what my own course, new course is going to be. And I parallel that back to the center. So I have a new course. Such a weird question. There's not even answers on it. Changing course over to 3-5 355, 356. So new course, 356 degrees true. So I am changing course to port a lot. I really don't like this as our first example because you're not supposed to change course to port. Let's do another one. This is change course to port too. Oh my God. Let's skip to number 4. I'm sorry. Let's skip to number 4. I should have looked at these ahead of time. Oh, this has changed speed. I do want to do change speed. Hold on a second. Okay, cancel that. Let's just do number 2. But I'm just going to erase the whole change to port. And we're going to change course to starboard if we're giveaway. That's what we're going to do. Okay, are you guys with me? I'm sorry, I'm a little hectic.
All
right?
good.
Okay.
I'm still with you.
Okay, so I'm on number 2 of our second triangle in class problem. I'm just changing that whole section right there. Okay, so they told us we were on course 160. So I'm going to create a heading flasher. There we go. Of 160. At a speed of 16 knots. So then they told me at 1628, we sight a large target on the radar scope bearing 192 at 10.4 miles. So 192 at 10.4 nautical miles. And we're going to label this R. This is our first one. Clean it up a little. Okay, so there's our R. And then 6 minutes later at 16, okay, this was at 1628. So at 1634, we see it again at 190 at 8 miles. 190 at 8 miles. I know that 8 miles is going to be right on that radar range ring. So there's our 8 miles, and that is going to be M. So we have 1634 is our M. Now we're going to connect our R and our M to get our relative motion line. So this is our relative motion line. R to M. Make this a little bit bigger here. See it. Okay, so they asked us what our CPA will be and what our TCPA will be. So we want to figure out what our CPA, that's closest point of approach along our relative motion line. So I use the triangle to get a perpendicular to my relative motion line. And this is our CPA. So we have a CPA of about 1.2 or 1.3. And our time of CPA we use that 6 minutes. Another 6 minutes. Okay, so we'll write this out. 34 plus 6 gives us 40, 46, 52, and 58. So I would say maybe 53, 1653 would be our TCPA. That's 1653. Our CPA was 1.2 nautical miles. So we want to change that. Well, first, let's see. Oh, sorry, got ahead of myself. Then they asked us, what is the contact's true course and speed? So we've determined that there's risk of collision. We don't like how close their CPA is. So now I want to determine what their true course and speed is, compare it to my true course and speed to see who is the giveaway or stand-on vessel. What is the situation we're looking at? So how I do that is I transfer my heading flasher, right? My own, the other piece of information we know is what I'm doing. So let me erase 16 there. So my heading flasher is 160 at 16 knots. So I'll get 160, parallel over to R, and I'm going to get my E. My E is going to be 1.6 from the R. So here is my E. So my E to R, zoom in a little bit here. So E to R, here's an arrow, is my own course and speed. So this is my heading flasher and my speed in 6 minutes. R to M is the relative motion line. E to M is them. The other ship's true course and speed is E to M. So we're going to connect E to M. I'm going to parallel it up so I can get what their, so the other ship's true course is, oh, 062 at a speed of 16 knots, 1.6. So here's them. Here's me. What situation are we looking at? Are we give way, stand on? We see their red light. They are to starboard of us, and this is a crossing situation. So we need to give way to them. They get to maintain course and speed, and we get to give way. So in our standing orders, they told us that we had an MX of 6 miles and a CPA of 2 miles. So our 2, 4, 6, 8, 10, 12 are already range rings on here, so that makes it a little easier for us. So at 6 miles, so there's 0, 2, 4, 6. So when this guy is 6 miles away from us, so right here, that is going to be our MX. That is when we are going to maneuver. We're going to wait for him to get 6 miles away from us, and then we are going to maneuver. And we want him, we get to maneuver for him. He's the stand-on vessel. We don't want to pass ahead of him. We want him to pass ahead of us. And our CPA is going to be 2 miles. So I'm going to bend. So I start with my MX. I can either go this way or this way. I'm going to go this way. Right? Yeah, I want him to pass ahead of me. Do right there. So this is my new relative motion line. So I have my new relative motion line, and now I'm going to bring that back to my other M to create a new triangle back here. So this is where I want them to travel so they can pass 2 miles away from me. So I am going to parallel that line back to this M. Is that the 8, right? So this is my new relative motion line. So I want my R to be somewhere along this line, my new relative motion line. My E to M don't change, my R will. So I'm going to maintain my speed of 16 knots. So I have my 16 knots. That was my speed right there. So my E to R, 16 knots. And then I swing my compass to the right, because I'm turning to the right, turning to starboard. And now where that swung arc crosses that new relative motion line, that point right there is going to be my R prime. So this was my R, this is my R prime, my new R. So now I can connect my E to new R. Missed it a little bit there. There it is. I'm going to parallel that over so I can see what course it actually is. And I am going to change course. So I changed course here to starboard, right? I'm changing course to starboard slightly to have my new course of 175. So I came to the right by 15 degrees so that this guy can continue passing ahead of me. Okay. They have a couple more questions here. What is your new time of CPA? And what is the bearing of our new CPA? And then what is the contact's new bow crossing distance? Okay, so let's start with our new CPA. So we created a new CPA, which is pretty close to the other one, but a little bit off. Oops. Again, I do a perpendicular line to the new relative motion line. So my CPA, my new CPA is going to be right here. So then my new bearing of CPA would be about 116. New CPA. 116 at 2 nautical miles. And then I wanted to know what the time of CPA is. So for finding the time, I need to change my time slots over. Excuse me. Starting at my MX. So I'm going to call my MX 1639. Then I'll get my 6 minutes. My new relative motion line has my new 6-minute mark. So there, there, there. So if this was 39, 6 minutes plus 39 would give me 45. That would give me 51 and 57. So I would call my time of new CPA 16. What did I say? That's 51. So 1652 is going to be my time of the new CPA. So again, we used our new R prime, right? Our new relative motion speed in 6 minutes to continue the speed down our new relative motion line. Then they asked us what the bow crossing, our new bow crossing distance. So we didn't draw in our new, oh, I kind of did. Draw in our new line. So we changed course to 175. And if they continue following the new relative motion line, where is that new relative motion line crossing my heading or crossing my bow to give us a bow crossing distance? So right here is that bow crossing. So I'd say it's just shy of 4 miles. We got, yeah, 3.8, 3.9, something like that. Okay, so I know there's a lot going on this page, but I want to check in with you guys. Is any of this making sense? Okay. Cool.
Little by little.
Little by little. Okay. We'll do another example. I don't know why it says change course to port, because that's even against the rules of the road. Really threw me for a loop there. Okay. Let's do number 3. Okay, I will try to go slower on this one. Yeah. Okay. So number 3, we have a course and a speed, and then we have range and bearing 6 minutes apart, and our standing orders is execution of 5 miles, CPA of 2 miles. Again, it says change course to port, and we are going to change that. Just delete that. Okay. So we are on course 050. So I'll give us our heading flasher. at 15 knots. So own ship 050 at 15 knots. Okay. At 1927, you sight a target bearing 045 at 10.5 miles. So 045 at 10.5. So let's find that. 10.5. And we're going to label this R. Okay. So that's at 1927. 6 minutes later, in 1933, we see it again, bearing the same 045 at 8 nautical miles. So this is M, and that was at 1933. Get this M bigger. Okay, so if I connect my R and M, I get a relative motion line that goes directly through me. So this is a CPA of 0. I'm going to wait a second, let you guys catch up a minute. So we have our R, the first one that we spotted. 6 minutes later, we plotted our M. We connected our R to M. So if nobody changes course and speed, we have a CPA of 0. Then they asked what our time of CPA is. So our relative motion speed, sometimes, or last week, we did a lot of what is the relative motion direction and speed. So you just get the direction, the speed, whatever this is in 6 minutes. Okay. So this was 33, so that would be 39, 45, 51, 57. So our CPA would be just past 51, maybe even call it 51, but just past 51. So I'd say our CPA is 0, meaning collision, at 1952, I'm going to call it 1952 is when we will collide. So that's our relative motion line. Now to create this triangle, move this M on the other side. Okay, so we have our R and our M. And now to create the triangle, we need to plot the E. What we do know is our own course and speed. So we can plot E to R, our own course and speed, and that will give us a spot for E. So my own ship's course was 050. So I'm going to parallel that 050 back to that R and draw in a heading line, or opposite of my heading. And my speed was 15 knots. So in 6 minutes, I would travel 1.5. We just move that decimal place over 1. So I have 1.5. Right there is going to be our E. So let's erase. Trying to clean it up for us. That was our M. So we have our M, our E, and our R. It's a very small triangle here. So E to R is my own ship. So E to R is in the direction of 050 at a speed of 15 knots. Relative motion is what was happening. Now E to M is them. That's what they are doing. So let's connect E to M. And figure out what their true course is. So our target's course was 215 at a speed of 11 knots. That's 1.1. So let's look at our situation. what kind of situation have we come across here? That would be a crossing, or excuse me, a meeting situation. And in a meeting situation, we both turn to the right. Both are give way, but we are going to turn to the right to avoid hitting this guy. So, and when in doubt, right? When in doubt, if we don't know if it's a crossing or meeting situation, assume that it's a meeting situation and turn to the right. So we are going to do our second triangle by turning to the right. So we're going to plot that. They told us we wanted an MX of 5 nautical miles and a CPA of 2 nautical miles. So I need to plot my MX, that's point of execution. So I have 5 nautical miles. So where does my relative motion line meet 5 nautical miles? This is my MX, my point of execution. So I want, I'm going to turn to the right. So he's going to come along my port side. So I am going to make, so 2 nautical miles is already a circle on here. So my CPA of 2 nautical miles is already a range ring. So I don't have to draw that one in. So I have my MX, and then I'm going to put this just on that 2 nautical mile circle and draw in my new relative motion line. So I have my new relative motion line, but I need to bring that back up to my original M so I can get my new R. Falling off the plotting sheet here. Okay, so there's M. So that right there is my new relative motion line. Now, if I don't change speed, so I have my 1.5, right, here's E, my 1.5, and I'm going to turn to the right. I want to turn to starboard, so I'm going to swing my compass here to starboard. So where does my new my arc cross my new relative motion line? Right here. So this is my R prime, or my new course line. So if I connect E to R, E to R, that is my new course line. So let's get what our new course line is. So we're going to come to the right, right? We're changing course here to 093. So my new course is 093 degrees. So my new triangle is E, M, and R prime. That is that second triangle. my original triangle was very flat, right? It was a meeting situation. Okay. The next question, 2 questions here, are what is the new CPA? And what is the bearing of the new CPA, and what is the time of the new CPA? So I do a perpendicular to my new relative motion line. That gives me a new CPA bearing 339 at 2 miles. And then for time of CPA, we need to figure that one out. So this was 27, 33, this was 39. So let's say our MX was at 1940. So then our relative motion speed changed. So we have to use our relative motion, our new relative motion line. So R, or M to R prime, is our new relative motion speed in 6 minutes. So I don't have the pencil here, but we have 1940, so 46. So write that. So here is 46. 46 plus 6 is 52. So here is 1952. So in this case, I would say it's just before 1952. So I would say our time of new CPA was in 1951. So not too different from our original, but yeah. Okay. How you guys doing on this?
Trying to absorb it all.
Okay. What is most confusing to you, or what can I spend more time on?
I think it's just more of getting and it's on the bottom of the plot sheet, but the E to R, R to M, M to R.
Yeah.
Once that sinks in, I should be good.
Okay.
As of right now, it's more of just I'm mixing them up.
Yeah. Keeping track of it. Okay. All right, let's take another 10-minute break. Let's come back at 8:30 and we'll do the last one on our in class, which is a speed change. So we'll see how the speed change happens. And then we'll dive into the homework. So yeah, keep practicing. And let's take a 10-minute break.
Sounds good. Be back at 8:30.
All right, is everyone back?
Back.
Okay. So we are going to do our last in-class question, which is question 4. And this is going to be a speed change. So flip this over. Okay. So we'll start out. They give us our own course and speed. And again, at 6, is this one 6? It is 6 minutes. 6 minutes apart. We are on the same bearing. So I can see our CPA will be 0, but we want a MX of 6 miles and our CPA of 2 miles. So let's plot that. So our first step is to plot our heading flasher. So our heading is 327. So here's 327. So that is our heading. And our speed, so own ship, 327 at a speed of 17 knots. So that is going to be my vector. And then I have at 10:23, we cite a target at 042 at 11.4 miles. So 042 right there. At what did I say? 11.4. So if this is 10 and this is 12, I'm going to be somewhere over there. So I'll get 11.4 on my dividers here. $11.4. And we mark this as R. Our first one is R. So we mark this point as R. Try to make it big and bold. So we have this point is R. 6 minutes later, we get another range and bearing. And again, we're just pulling this off of the radar at 042 at 7.2 miles. So same bearing, but 7.2. So that's going to be 10, 8, somewhere along that line. So we'll find 7.2. And we label this one M. So we have our R to M line. We have an R and an M of our triangle right now. When we connect our R to M line, we get our relative motion line. So if nobody changes course and speed, our relative motion is going to lead to a collision course. So risk of collision exists, and I want to figure out who has the right-of-way, who's the burden vessel, who's stand-on, etc. So the next thing to plot is my own vector, so I can see what they are doing. So my own ship's vector down here on the bottom is E to R. So I need to plot my E somewhere. So I paralleled my own ship's heading was, what was it? 327. And I bring that up to the R. And then I could, so I know somewhere this direction is 327. That's my own ship's vector, but I don't have a length of it yet. Now the length of it is going to be 17 knots in 6 minutes. So I use that 60D street. But we know in 6 minutes, I just have to move the decimal place over 1. So I get 1.7. Pencil's dying on that end. 1.7. Right here is going to be my E. Now I could look at my triangle and I have E to R is my own ship at 327 at 17 knots. R to M is the relative motion line. E to M is them. It's the other ship. So if I plot E to M, connect those two, I get their vector. And I parallel that down to the center so I can read what that course is. So their course, so the target's course is 245. So the target is going in this direction, right? At M, it's pointed this way. That's what the target is doing. Its course is 245. Its speed is going to be a lot faster than my speed. E to M, so that's how fast it traveled in 6 minutes. It's going 40 knots. That's hard to believe. It is. It's going 41 knots, it says. It is a very fast-moving object. All right. So course 245, speed 40 knots. So they're going this direction, and I am going this direction. Now I need to figure out who has the right of way, who's the burdened vessel. So with our rules of the road, we have a green light, a red light, green light, red light. So from us, we see a red, so we stop. They see our green, so they have the go ahead. They're the vessel to starboard, so we have to give way to them. They stand, maintain course and speed. So we're going to be turning to starboard. And this relative motion line is going to move what they call up scope, or it's going to move in front of us, because we want them to cross in front of us. We basically want to head for their stern. We don't want to cross in front of them. Any vessel that is stand on, we want to avoid crossing ahead of them. We want to turn to starboard and cross behind them. Okay, so my NX was 6 miles away. So I have 2, 4, 6. That was my RNG. Clean that up. Okay, so here at 6 miles, this is my MX, my point of execution. So that's where I'm going to change speed or bend this relative motion line. And then my CPA is 2 miles. So that 2 mile range ring is already on here, so I don't have to draw another one. So I'm going to connect my MX point and then place my line just tangent of my 2-mile range ring. So just touching there. So this is my new relative, and my new relative motion line. There we go. So now, in order to go back to the triangle, I'm going to move my relative motion line back to this M so I can get a new R. So I'm basically transferring the new relative motion line back to my triangle. So I line up my new relative motion line, make it longer. Bring it back to the M. So, oops, there's my M. I jiggled it there, hold on. But I wanted you to see what M is. Okay, so here's my new relative motion line, and I'm going to go from the M of my triangle and draw in my new relative motion line. So this was my old relative motion line, and this is going to be my new relative motion line. So from E to, if I was to change course, I like to do both anyways. If I was to change course, I always swing my compass here to the right because I'm changing course to starboard. So I have an R prime there. If I'm changing course, so I have E to R is going to be my new course. But in this case, they wanted us to slow down, to change speed. So we're maintaining course. So E to R vector is going to be in the same direction, but the length of it is going to be smaller. So where does this line cross my E to R vector? Right here. So that is my R prime if I'm changing speed. So if I'm changing speed, I'm going to slow down to see this distance gives me 0.4. So my new speed is 4 knots. So if I don't want to change course, and this guy is crossing my bow, then I need to slow down to 4 knots from my 17 knots in order to let him pass 2 miles ahead of me. Okay. I want to do the time CPA because this is a good example of this with the change of course. So did the change of speed make sense for you guys? Is that all right? Okay. Change of course, it's not exactly on the question here, but if we were to change course instead, I would connect my E to R prime. Right, I just connected those dots, and then I bring it to the center so I can read what actual change of course that is. So that was 0.48. So if I do a new course, it's 0.48. And this is my new R. So if I want to figure out what time of my CPA will be, I need to figure out my times first, which I didn't do that earlier. So if this is 6 minutes, relative motion speed, right? That is, I'm going to say 4.2. So half of that is 2.1. So I'm just halving 6 minutes to 3 minutes. So it's a little more visual for me. So this was, did I have a time? 23, 29. So 3 minutes later, this is going to be at 32. So my MX, let's call it 31. My MX is at 31. And then I use my new relative motion line to get my new relative motion speed. So that new relative motion speed, R to R prime, is the speed that I'm using. So if this is 31, this is 6 minutes later. And this is 6 minutes after that. So 31 is 37. So I would say time of our new CPA using that speed change is going to be 10:37, 10:38. New CPA time 10:38. Because we were using the new relative motion line. If you do the speed, you just use the new relative motion line on the speed, wherever your R is. Okay. Making a little sense? Okay. Does everyone have the homework printed out? Let's start, or take a breather, or if you don't have it printed out, you can still use your radar maneuvering sheets and we'll just plot it on there. I'll probably do that just to make it bigger anyways, easier to see. But let's dive into the homework. So if you guys have maneuvering boards, who does not have a maneuvering board right now? Okay, cool. So get your plotting tools and your maneuvering boards, and let's start on the homework. Excuse me. So go ahead and start plotting. If you don't have the homework, I'm writing it here. So this is our time, this is our bearing, and range. Own ship is 160 degrees at 15 knots. There we go. We're going to maneuver at time of 12 minutes with a CPA of 2 nautical miles. So I'm going to give you a couple minutes here to start this plot, and then I'm going to catch up with you. So go ahead and start plotting. I'm gonna adjust my lights. All right, how we doing? You guys get
Yeah,
pretty far
all
on
good.
it? Okay.
We're plotting the other ship right now.
Okay. Okay, so I'm gonna start plotting it. Keep going, doing whatever you're doing, but I'll eventually catch up to you. Again, I do things a little bit quicker. So we have our own ship at 160. Then we had a 210. And a 211. So this 0, 6. So I have my relative motion line, my R and M at 0 and 0, 6. Then I'm going to plot my E so I can figure out what they're doing. So I parallel over my heading. And my own ship was 160 at 15 knots. So I'll use 1.5. And I have my E. And I can connect my E to M. And I get them. Oops. Parallel this up to the center. So I get the target's course was 0.73 and the target speed is 15 knots. So on this problem, they told us that our mx is a time instead of a distance. So it's at minute 12. So if this takes 6 minutes, then our minute 12 would be right here. So this is our mx. And I forgot to do this before, but we'll put our votes on it. If we look at it, who has the right of way, who is give way? So they are stand on, we are give way. This is the vessel to starboard. So they get to stand on, and we're going to turn to starboard. So their relative motion line, we're going to pass in front of us. This is our heading, and I want their relative motion line to pass in front of us so that I go to their stern. So when I bend this, a new relative motion line, I'm going to go to this side of the 2 miles, right? Our CPA is going to be 2 miles. My MX was at minute 12. Oops. Wait, when that happens. So here is going to be my new relative motion line. So it's going to cross in front of me. So now to find out what my new course or my new speed is, I'm going to parallel that new relative motion line back to the M in my triangle. So I start on my M, and I have my new relative motion line. And then if I want to change course, I keep my my distance of this vector at 15 or 1.5 for my 15 knots. And I turn it clockwise, which is going to be to starboard, right? If we turn to starboard, we're turning clockwise. So I'm going to move my little dividers here clockwise. There we go. To moving them clockwise for my turn to starboard. So this is going to be my R prime, my new R. So I'm creating E to R and M as my new relative motion line or new triangle. So I connect E to R for my own ship. And then I bring that to the center so I can measure it. And I get a new course of 210, 15, 16, 17, 217 degrees. If I wanted to change my speed, my R would maintain on my heading or on my course line, but my R prime would be a lot shorter. So if I wanted to change to a different speed, I would slow down to 5 knots. New speed, 5 knots. In the question, let's see, what do they ask us? Our new CPA due to our course change, what is the time of CPA and the bearing of that CPA? Okay, so we created our new relative motion line. So to get CPA, I do the right angle to the relative motion line, So that's going to be my CPA. So my bearing of CPA, my new CPA, is going to be 147 degrees at 2 nautical miles. And then my time of new CPA, this was at minute 12. So let's get my minutes here. That was 12, 18, 12, 18, 24, 36. So I might call it 24, 26. I might call my time CPA at minute 26. Again, the time is plus or minus 3 minutes. So you have some wiggle room there. How'd you guys do?
I have a quick question. With the new CPA that you did, that right, why did you have to do it at a right angle?
So that's the quickest way for me to get it. It's the point of tangency on this circle. So you could eyeball it for sure. But just to be as most accurate as you can be, a point of tangency will be 90 degrees to the center. So just like if I was to find my CPA on this relative motion line, that, you know, it's 2 miles away here, it's getting closer, I would say somewhere around here is my CPA, and then it gets farther and farther away. But just to be as accurate as possible, I do a right angle on my relative motion line to the center, which is me. And I can see that right there is going to be my CPA. So another way to do it is to make a tangent circle and just measure it like that. But I find it harder to use the compass and quicker just to do the right angle. So it's just the point of tangency on the circle, but the quick way to do it is to use the right angle.
Okay, thank you.
Yeah. All right. You guys ready to do another one? So I'll take a breather. How we feeling?
Yeah, we can do another one.
All right, let's do exercise 3. I will write it out. Exercise 2, did I say 3? So we have time, bearing, range. My own ship is 317 and 20 knots. Net 0. How you guys doing on it?
So I'm stuck in the part because I already did the new RML line.
Okay.
And I got my, I did my relative line of motion. I forgot how to plot the let's see, the ER.
Yeah. So you want to create the R prime, right? The new R to put it on our new relative motion line.
Okay, can you show me that really quick? I don't
Yes.
remember.
Yes. Okay. I'll plot it real quick. We have 2, 10. Let me go up here. Okay, so we have R and M. We have our E.
Okay, so she does it on the R. That's what it is.
Okay, so they are going this way. We are going this way. We're going to bend our line at 4. So 2, 4. Here's our MX. We're going to bend our line to 2 nautical miles. Bring that up. So you got this far, right?
No, what I was saying is I was confused by the E. When you got the E.
How I got it originally?
Yeah, how do you get the R to the E? That's what I forget.
Oh, okay. So I plotted my R to M, right? My R and M. And then the other thing I know is my own ship's course and speed. So I'm paralleling my own ship's vector to R. So I am going.
That's what I was confused about because I was plotting it to the M because I assumed we were going off of the newest time. Why do we go to the original one?
So E is going to be the base for everything true. So E to R is true course and true speed for me. E to M is true course and true speed for them. So we have to have something ending in the M to get what their true course is.
Oh, okay. That's what I was confused about because I was going off of the M, not the R.
Okay, so we go all the way back to the R, so we get that REM triangle.
Okay.
So then we get M. That's the important one. So from here, we move our new relative motion line to the M. So we do something from the M. Because this is from MX, so we're bringing that M back to this M.
And then how do you get the M to the E?
For the original first triangle?
The distance from R to E, how do you get that again?
That was our
Yeah, for
speed.
the original.
So we
Oh,
drew
okay.
we drew the line. So we're creating this line is my own ship. So we're using what we know. My ship's course, E to R, and my ship's speed, which is 20 knots. So we use 2 miles.
All right, got it.
Okay. So then you can get your E to M, which is their true course and true speed.
All right, thank you.
Yep. Okay, so figuring out their true course and true speed, we can see that they are stand on and we are give way. They are cruising this way. We are cruising this way. So they have the right of way. We need to give way. So we're going to let them, their relative bearing line, cross in front of us. So we have our MX at 4, CPA at 2, and then we parallel that RML line, the new relative motion line, back to M. So we start at the MX here, and we bring it back to this M up here in this triangle. Let me erase this real quick. And we're creating a new triangle here, or they call it the second triangle. So I want to get a new R. So my E is going to stay the same. My E is kind of this base point. This is where the true vectors for me and the true vectors for them, the other ship, start from. So E stays the same. My relative motion line has changed. So it's not this one anymore, it's this one. So in order to change it, I'm gonna get my 2 miles. It's a little sloppy on that one. So here's my.
And then how did you get that MX line right there? The first one?
Yep. So MX was at 4 nautical miles.
Yeah.
With a CPA of 2 nautical miles. So when that target is 4 miles away, so this is 2, 4, 6, 8, 10, 12 on our range rings. When that target is 4 miles away, that's when our point of execution is.
Cool. Okay.
And then we create 2 mile CPA. So this is going to be our new relative motion line.
Okay, got it.
Yep. Then we move that new relative motion line up to the other M.
Okay.
And then we want to figure out where our new R is, our R prime. So we have, if we're going to change course, we keep our speed. So E is that base point for everything true, right? So E, if we keep our speed, then I want to know if 20 knots, where's E and the 20 knots going to cross this line? That's going to be right up there. So I'm going to have an R prime right up there. And with this measuring, you always turn your compass or your dividers to the right because you are turning to starboard. You measure your E to R and bring that back to the center so you can get a measurement. So what did you get for your new course?
All right, so I got 3, 12, 26, 58. I got 358.
358. That is what it says the true answer is. So I am off of by 4, but 358 it says is the true answer.
Cool.
Yeah,
Thank
you. Very cool. So then it also asks what would be the new speed if we can't do a course change.
Okay. For that, does it like, do I come up with the speed, or that's what I don't understand? It's like, how much do you slow down?
So that's what this triangle is telling us. How much to turn to the right and how much to slow down if we want this exact CPA, right? If we want the CPA of 2 miles and we're going to do whatever maneuver we're going to do, slow down or change course, when that target is 4 miles away from us, this triangle is telling us that we would change course over to, due north, essentially, or we would change speed. So our E to R direction would stay the same, but our E to R length would be smaller, would be a slowdown. So that would be R prime. Zoom in there. So that E to R1 right there. So what speed do you get?
Like 1.4. So let's see, 14 knots.
14 knots. So it is 12 knots, but you can give or take 3 knots is the wiggle room on that. So that would have been correct.
Okay. Is that all it asks? Is just the new course and speed for answers like this?
New course and new course or new speed, and then it would ask what would be the time of new CPA. So so where would our CPA be on our new relative motion line?
Or no, technically it'd be like this. Right. Why is this confusing me? Hold on. Yeah, she's measuring off of.
Okay, so
Are you doing the CPA off of the RML, right?
yes, that new
The-
relative motion line.
Okay.
So our original relative motion line gives us a CPA of 0. It goes directly through it.
Are you doing the RML off of the 4 nautical mile one?
Correct.
Okay.
So the 4 nautical mile meets the 2 nautical mile circle. Where does it meet that 2 nautical mile circle? Right about there.
Okay. See, that's 25. Would it be like a CPA of like, 27 minutes or something like that?
Yes, so let's do the timing together. I already wrote it on. But 6 minutes is from R to M, right? R was at 0, M was at 6. So I walk it, that's 12 minutes. That's 18 minutes. So I'm calling MX minute 19. So that's when things change at minute 19. And following this relative motion line, that speed of relative motion has changed because it's M to R prime instead of the original R to M. It's the new R and the new M. So this is still 6 minutes, but this is what the relative motion is going to be on my new line. So there's minute 19. I add 6 minutes, so there's 25. 6 minutes to 31. So now I can say about 27.
Okay.
So if we did the 6 minutes, our original 6 minutes, to minute 18, we would get, or 19, 25, 31, so we would get like 32 or something, which would be more than our 3-minute window. So you want to make sure when you're moving on the new relative motion line, you're using the new relative motion speed.
Okay. Cool.
All right. That's all I have for today for you guys. I will stay on here until about 10:15 if you guys want to keep working. I'm happy to answer your questions. Or if you want to knock off, that's cool too. But remember, at the start of next week is going to be a quiz. So it's going to be just like this. It's going to be a single target. What's its original CPA? What's the situation? If you change course, what's the new course? What's the new speed? Etc. So you're welcome to use your notes, any materials or any examples during the quizzes, but the quizzes will be graded. So you won't have the answers The quizzes will be graded, but you're welcome to use your notes and materials. So next
Is this
week starts our
considered
quiz.
still first triangle?
This is second triangle. So we have
Okay, this is
our first triangle is the original, and the second triangle is with our course change.
okay, cool.
And then the next step for this is multiple targets. So we're going to have more targets around us, and we have to establish which one is has risk of collision, and then do triangle 1 and 2 for the one with risk of collision.
Okay.
So yeah, that's what we got. I will write out number 3 if you guys want to do it, but again, up to you. Oh, that doesn't work.
I'm sorry, can you walk me through this one?
There we go. Yep, no problem. Okay. So we have our own ship at 100. At 12 knots. I'll just write that. Own ship. 100, 12 knots. Okay, and then we have a bearing of 116 at 10. So I know that this line is 10, so I have 116 at 10. So I'm going to label that R. And then I have 115 at 8, which is that other range ring. So I'm going to label this M. So I have my R and my M. This was at 0, and this was at 0.6. Are you with me so far? So then I'm going to connect my R and M to get my relative motion line. So this is my relative motion line. So if neither of us change course or change speed, they are going to cross ahead of me. So I have a bow crossing of 2 miles here. So I'm going to see what exactly my CPA is. Just R to M. So I'm going to use my triangle to get a perpendicular line. So my CPA, this would be my CPA. Has a distance of 0.7 nautical miles. So I'm not comfortable with the 0.7 nautical mile CPA. So I want to figure out if I am stand on or give way, what the situation is. So I need to plot E to form this triangle. So R to M is the relative motion. E to R is my own ship's motion. And I know what my own ship is doing. I'm headed at 110 at 12 knots. So I'm going to parallel this 110 line back down to R so I can get an E to R line. So I'll get my 110, or excuse me, 100. So from R, I've just paralleled this line. Now I need to figure out where my E is going to be on this line. I'm doing 110 degrees at 12 knots. So in 6 minutes, I would travel 1.2 nautical miles. So I'll find 1.2 over here. And from my R, I have 1.2. So this would be my E. So E to R matches my own ship. the direction of 100 at 12 knots. Relative motion was what I observed. And then E to M is going to be them, their course, true course and speed. So anything from E is going to be that true course and true speed, not relative. So have you plotted E?
Sorry, muted there. No, it just do not plot E there.
Okay.
Okay.
Okay, so we got E. And now I want to figure out what E to M is. So what is the target's true course and speed? So I'm going to be measuring the vector of E to M. So first I'll draw the line. E to M. Oops. That's all right. And then I'm going to bring it back to the center. Didn't work out. E to M. I bring it back to the center so that I can measure what its direction is. So that is E to M is that direction. But in order to measure it on the edge of the plotting sheet, I have to measure it from the center. So I have a target's course of, let's call it 328. 328 degrees. And then I want to target speed. So I measure the distance. So speed, distance, time. In 6 minutes, it traveled, we'll call it 0.9. Oops, can't see it. About 0.9. So we'll say the target speed is 9 knots. So go ahead and measure your E to M. Well, they don't have it.
Yeah, am I muted? I'm not muted. I got 9.
Okay, cool. And did you get the course?
From E to M?
Yeah. What course did you get?
I didn't draw it, no. It's gotta be lined up at the center, doesn't it? That can't be right.
You gotta bring it down to the center, dummy.
No, because it's going this way.
You gotta bring it down to the center and then read
Yes,
it.
but it's going up.
Yeah. Read it that way now.
That's what I was already doing.
No, because you still had it here. You gotta bring it down. Look. Then you read
You
it.
have to line it up first, though, don't you?
You line it up here.
And then you bring it down.
Yeah.
This is exactly what I was doing. Thank you. Excuse me.
Okay.
Give it a second, will you? $311.
I got 328. So
Very off.
A little bit, yeah. You want to be within 10. So
Okay, so
call
now
it
that tells me
318. And the thing with this one is that E to M is so small that like your dot, you know, how big your circle is can throw you off one way or another.
yeah.
So yeah. But you were ballpark, so I think that's fine. Okay, so if we're looking at this, this is us and this is them. So, like all of our questions here, they are the stand on, we are the give way. Because they are to starboard. So
Yeah.
we have to give way to them. We're going to turn to starboard. We're going to turn to the right, and they're going to continue with their course and speed. So with my relative motion line, or they told me MX was at 12 minutes with a CPA of 2 miles. So this time our MX is in minutes and not in distance. So it can be either or. So to find my MX of, or my minute 12, this is 6 minutes. So I'm just gonna double that and say that this is 12 minutes. So this, my MX at minute 12. So this was 0, 6, 12 minutes. And then I want my CPA to be 2 nautical miles. So it's going to be around that 2 circle. And I want it to cross in front of me so that I will go behind that vessel. So I'm going to draw a line from MX to just barely on that 2 nautical mile circle. And that is my new relative motion line. So go ahead and get a MX and a new relative motion line. So our MX was 12 minutes. Our CPA was 2 nautical miles. So this was 6 minutes. I measured what my relative motion would be in 6 minutes because this was at minute 0 and minute 6. So then I just walked it over to see where minute 12 was. And I marked that and said, that's my MX for minute 12.
Okay.
And then I want a CPA of 2 nautical miles. So from my MX, my original relative motion line crosses, you know, with at 0.7. So I want to bend that line to 2 nautical miles. So it stays outside of my 2 nautical mile CPA circle. So I'm going to draw that line from my MX tangent to my 2 nautical mile circle. And that gives you a new relative motion line. Then your next step is to move this new relative motion line. So from your MX, it goes this direction. We want to move it back to the original M and draw it in this direction. So I'm going to parallel. This is my new relative motion line. And then I'm going to bring it back to my original M. So not the MX, but the M. And I'm going to go backwards for the reciprocal direction. So now I have, no, I didn't do it quite straight, but that's okay. Made it a thick line. So this is my new relative motion line. Same as this line. They're the same line. So now I need to create a new triangle. So this was my original RME. So my E is going to stay the same. My M is going to stay the same, but I need a new R. So if I was to change course, I keep my 12 nautical miles. That's my E to R. Let me do it on this one so it's a little more accurate. So E to R was 12 or 1.2 nautical miles for 12 knots. So if I keep my same speed, where does this line hit my new relative motion line? So I just kind of swing this to the right, and it crosses right pretty much on that line there. And we'll call that R prime, or my new R. So now I have a new triangle of, here's R to M, that's my new relative motion line. And then my E to M is their line. They didn't change. They maintained course and speed. So that line never changed. And then my E to R is my own ships. And that is going to change as I change course to the right. So I'm going to measure that E to R. And so I drew my little line, but I have to bring it back down to the center so I can actually get a value to it, a number to it on the compass rose, if you will. So I'm going to change course to 122. That is going to be my new course. So I was at 100, and I'm going to come right to 122 so that they will cross ahead of me. If I want to change speed and maintain my heading, so E to R is same direction but different speed, I get what the new speed would be there, which would be like 5 knots. So go ahead and plot the new RML line on the new triangle to get a second triangle and see what you get for course change.
I got it on 120.
Okay, that's great. I got 122 and you want to be within 10. So that's great. Okay, that makes sense?
I'm gonna need some time to go over it tomorrow, but I should be
Okay.
caught up by then.
Okay. Well, I'm going to make my videos tomorrow and post those. So you can check out those. You guys can go back and check out the lecture from last week. It might make a little more sense to you. But feel free to email me anytime if you want me to walk you through one. So remember
Okay.
the quiz next week and to submit your little homeworks for on Canvas.
Yeah. Okay.
All right.
All right. Thank you.
You guys have a good one.
Sorry.